Good afternoon to all. I am Romila, Assistant Professor of the Department of Information Technology. The subject code is CS3452. The subject name is Theory of Computation, Regulation 2021. So the core outcome of theory of computation is first one is construct automata theory using finite automata CO2 to construct models of regular expression and languages, and CO3 to design context-free grammar and full-stone automata, CO4 to understand learning machines and their capability, CO5 to understand undesirability and NP class problems. The syllabus for the theory of computation was Unit 1 Automata and Regular Expression, Unit 2 Regular Expression and Languages, Unit 3 Context Free Grammar and Full-Stone Automata, Unit 4 Normal Forms and Turning Machines, Unit 5 and Desirability. And then going to third unit, what is a grammar? The grammar means set of rules used to define languages. The specifies how strings in languages are performed. So definition of grammar means four tuple representation. It is G equal to V comma T comma P comma S. So the next one, the context-free grammar. The context-free grammar is a type of grammar in which each production rule has a single non-terminal on the left-hand side. So CFC also for tuple presentation. The CFC equal to V comma T comma P comma S. So the V means variables. It's also called set of non-terminals. So T means set of terminals. P means the set of production rules. The S means start symbol. So components of grammar means one by one is a detailed explanation by the four tuple representation. First one is variables, is a non-terminal values. So I used to derive strings. For example of A, capital B, capital S, and capital X, capital Y. So it is denoted by capital letters. So terminals means denoted by T. So it means actually symbols of the languages. So in the final string, so examples for alphabets of small letters A to Z, the digits means 0 to 9, the symbols of plus operator, minus, and multiple operator and division operator and close bracket and open bracket. So next one is the production rule. Production rule is a type of four types of rules. So first rule is rules to replace non-terminals. So non-terminals means like A, S, and B. So the symbols are that can be expanded. So second one is rules show how a non-terminal can be replaced by the terminals and other non-terminals. So examples. So X denoted by capital A of S. So the non-terminal S is replaced by A of S. So general form is second one is general form alpha denotes to beta. So the production rule is written by alpha denoted B. So the replaces of alpha with beta. So the example for A denotes to AB. So this means A replaced by the AB. So the third one rule is alpha and beta are strings over variables union of terminals values. So variable means also called non-terminals. So example for A, S, B. So terminals also small letter of A to Z and numbers of 0 to 9 and operators plus and minus multiplication and etc. So this third rule is variables union of T. So both non-terminals and terminals are together. So the alpha and beta can be contained terminals and non-terminals are both time used. So the example for capital S substituted A of and A S B. So here A B are a non-terminals. S means a non-terminal of capital letters. So beta has a mixture of both. So fourth rule is at least one symbol in A alpha must be a non-terminal. So this rules means the left side alpha must contain at least one non-terminal. So it is allowed to replace only non-terminal values, not terminal values. So the correct rule is A, capital S of substitute by small a, capital A of substitute by A B. So because A and S are non-terminal values, the wrong rule means A to B. So not allowed because A and B is a terminal values. And then start symbol means it is a special variable. So derivation of strings starts from yes. So example of start symbol is yes, denoted by A of SB, and other one is denoted by epsilon. So example grammar means b equal to capital non-terminal values. So yes, and then t equal to terminal values a comma b. So p equal to the production rule. So example production rule is substituted by the production rule. So s equal to start symbol. So one example problem CFG. So write the tuple of CFG. So S denoted by A of A, S denoted by B, and S denoted by triple A. So solution of this example. So grammar means four tuple presentation, and V T comma P comma S. So V equal to capital letters and also non-terminal values. So S comma A. So T means terminal values. So A comma B. So P equal to the protection rule. So given protection rule is wrote in protection rule, and then S denoted by A of A comma S denoted by B comma S denoted by triple A. So S is also start symbol. So the another one example for CFG, A of n and B of n equal to, and then n greater than equal to 0. So this set contains all strings of the form. So sum of numbers of A's followed by same number of B's. So n greater than 0 means n can be 0, 1, 2, or 3, and then etc. value. So n value of string is A of n, B of n. So n equal to 0 means epsilon. So empty string. So n equal to 1 equal to AB. N equal to equal to triple A triple B, and then n equal to 3 triple A triple B, and n equal to 4 4A 4B. And then so the languages L equal to first one is epsilon, comma AB, comma AABB, and comma triple A triple B, and 4A 4B. So this language how is language generated by using CFG. So a grammar that generates the language is protection of capital S equal to A of SB. So S substituted by epsilon. So step by step derivation means generate the one string WA double B. So S is a start symbol. So S denoted by A of SB. So and then A means A, and then S substituted by A of ASB, and B last one is, and then and the small capital S start symbol of substituted by one A of S B. So S is belongs to epsilon also. So A, and then BB is generated by the language. And then second one is our an example. Construct the CFG for the language which includes all even length palindromy strings over a epsilon equal to A comma B. So input symbol is A comma B. So in the palindromy means so same forward as well as backward. So the alphabet means already know this alphabet is A comma B. So language means even length palindromy. So L equal to first one is epsilon. Even length means even numbers 2, 4, 6, 8, and something etc. So first language is starting first epsilon comma double A double B, AB BA, and then BA AB, and then 4A 4B. So all strings are palindromy for even length. So the production rule is S substitute of A S B, and the S substitute of B S B, and then S substitute of epsilon also. So first one is proof of derivation is the example of the one string is BAAB. So S is the start symbol substituted by S substituted by BSB. So B is rules, and then S denoted by A of S A, and then last B is substituted. So and then B is also here. So A here, and then S belongs to epsilon, and then A here and B here. So last final string is A B is a belongs to L. And then odd length palindromy, one example for language is odd length. So odd number is 1, 1, 3, 5, 7 and 9 also. So odd length is languages. First one is A comma B A B, and triple A triple B, and A B B B A, and B A B, and for 5A 5B. So CFG for odd length palindromy means as the production rule is S substituted by A S A, and then A substituted by B S B, and A substituted by A, and S substituted by B. So proof of example is the string, one string is A B A. So S is the start symbol. So substituted by A S of A. So A is already here. So S substituted by B S B. So and then last A one is already here. So A here and the B here, and the S is a substituted by B. So and then B here, and then A here. And the final string is A B B B. A is getting we odd length palindromy. So thank you so much.